The area we study is so remote.
The landscape is beautiful and bizarre and strange.
Pushing a raft into a cold Arctic lake for a day of scientific research was exactly the kind of summer experience Everett Lasher had hoped for as a PhD student at Northwestern University.
I consider myself very fortunate to be able to spend a month and a half in the high Arctic at 70 degrees north.
Lasher is part of a small team of geologists led by Northwestern University professor Yarrow Axford, studying climate change in the Arctic. Axford has been to the Arctic 16 times to study geology and the rapidly melting Greenland ice sheet.
We know from observations by satellite and from radar based on aircraft that the ice sheet is losing mass to the sea today. It's contributing to global sea level rise. But it's very hard to know what its future will look like.
Axford's team specializes in pulling samples from the bottom of Greenland's Arctic lakes to investigate climate changes over the past 10,000 years.
We go into the field to try to recover tubes full of the mud that accumulates at the bottom of lakes year after year, and that mud contains just a huge range of things that tell us about past environments. Everything from pollen grains from the plants that grew around the lake in the past to insects that live there, mineral grains that tell us sort of what was happening in the landscape surrounding the lake. Even the chemistry of the water tells us something about the environment.
It's dirty work. I mean, you're pulling sediments out of lakes, and everything you collect is what you get to use in the lab. It is very hands-on, but you have to be really careful.
We nailed it.
Carefully collecting samples is a priority, but so is staying safe. Getting to the study site requires military and helicopter transport. Their campsite is surrounded by an electric fence to ward off polar bears, and the harsh summertime weather of northern Greenland is always a concern.
This is what research in the Arctic is all about.
But traveling far and roughing it for a while is worth it for the data-rich samples the team brought back to Northwestern.
To get out there and spend those 7 weeks and have it go so well, to recover an incredible record, what we think is an incredible record, and now to have it back here in the lab, at our hands, at our fingertips, it's an awesome feeling. Something, I mean, it's going to keep us busy for the next 5 years.
I started pulling chironomids out in the last maybe month or so, and I'm starting to build a temperature record.
Chironomids are tiny insects commonly found in the sediment samples. The scientists use them and other organic materials embedded in the mud to establish timelines, temperature history, and environmental changes through radiocarbon dating and other scientific techniques. This work will be used by scientists around the world who are urgently trying to predict how the Earth's ice sheets will respond to a warming climate.
It really matters to civilization, where our coastlines are. And where our coastlines are is determined by how much ice we have on land globally. The Greenland ice sheet and the Antarctic ice sheet are the two things that matter most to deciding where coastlines fall.
As climate change becomes more of a global concern, expect to see more Northwestern scientists in the Arctic, digging into the past to better understand future climate change.